Bismillahirrahmanirrahim. In this video, I'll be solving practice problem 10.4 from the mesh analysis. So let's see. This is the question. Calculate I0. So this current is I0 in this branch. So we have to calculate this in the circuit figure 10.11. So this is the circuit. Now if you note carefully, there is a current source between two meshes. So whenever there is a current source between two meshes, then this becomes a super mesh question. Although you can solve it without going to super mesh, but this is an easier way that you consider it as a super mesh and solve following the techniques of super mesh. Okay, so how do we proceed? First of all, we mark all the currents and we name them. So this is I1, I2 and I3. And then also it is a good practice to mark the voltage polarity. And we know wherever the current touches that point becomes positive. So positive, positive, positive for this one. Similarly for this is positive, negative, here it is touching positive, negative. So you mark all the polarities. Okay, so this was the circuit where we have marked the current directions and we have also marked the voltage polarity. Now as I mentioned that because of this current source between two meshes, this is becoming super mesh, and I hope you recall the technique that we remove this current source as shown here. So we remove the current source from here and write the equations. Now first of all we'll write equation for this one, and then we'll write equation for this super mesh, and there will be another equation for the current at this point. So let's see. Mesh 1, we write KVL, we start from here, so minus 60. And since the angle is 0, so there is no point writing angle 0. Had it been any other angle, then we should have carried this forward. But 60 angle 0 is same as 60. And we are going from here, so the minus sign first, so it will be minus 60. Then we have, although we have plus sign, so we write plus sign 10 into I1. 10 into I1. And then again plus sign and minus J4, so plus sign minus J4, and now there are two currents here, I1 and I2. So we'll write I1 minus I2 because we are in mesh number 1. So I1 minus I2. Then we come to at this place, 5 ohm again. We have two currents, I1, and this is going the opposite direction. So it will be I1 minus I3 is equal to 0. And we'll now simplify, we'll take the like terms together. So these are the terms, we have just separated I1 terms, then I2 terms, and this is our final equation. Everything I1 terms here, I2 terms and I3 terms. And now we come to the super mesh, and the equation from here again we start from any one point. We starting from here, so it is now plus sign, but we have minus J4, so we write minus J4. And now since we are in this mesh, so I1 will be the superior, so we'll write I2 will be the superior, so I2 minus I1. So minus J4, I2 minus I1. Then we come here 8 I2, so J8 I2. We come here again minus J6 I3, minus J6 I3, and here again we have two currents, so 5 I3 minus I1, so 5 I3 minus I1. And here also we can we have to find all the like terms. I hope you can pause the video and follow how I have done it. So this is our second equation. Now, as I mentioned that so we had two equations and we need one more equation because there are three variables. So the third equation we'll get from the super node again at this point of the node. So I am just calling it Supermesh, sorry, not super node, Supermesh. Supermesh 2, and this here at this point you can see that current I2 is entering, current 2.4 ampere is entering, and I3 is leaving, and therefore we can write this that I2 plus 2.4 is equal to I3. So this is our third equation, and from here we can plug in the value of I3 in the above two equations. So we'll eliminate I3. So putting in the value of I3 in equation number 1, here we have put in I3, and then solving and collecting the like terms, we get equation number 4. Similarly, putting the value of I3 in equation number 2 here, and then simplifying and collecting the like terms. So this is our second equation, that is equation number 5. So now we'll be dealing with these two equations and two variables. Okay, so these two equations, and we can there are several ways that you can solve. You can find the value of I2 from here and plug in here, but the easiest way is that we write it in form of matrix. So this variable here, second, third component, and the fourth component, and the two currents, and the two output voltages. So this is in matrix form, and now it will be easier to solve with the help of your calculator. So we'll use our calculator to solve this, and simply we know that we are interested to find current I1. So I1 is delta 1 over delta, and you know that this is delta, so we write it here. And for delta 1 we replace the first column with the output voltage. So we replaced it with the output voltage, and now we can do simple solution, cross multiplication, 72 multiplied by 5 minus J2, and then minus cross multiplication of this, and similarly the denominator, cross multiplication this minus cross multiplication of this. And again, I have a video on how to calculate the 2 by 2 matrix with the help of calculator, but here I'll just simply use the complex function of the calculator to calculate this, and once we are done we get this answer 6.08, 5.94. Now this is I1. What we are actually asked to do is find is I0, and so you can see from here that I0 is same as I1, and so we can write that I0 is I1 is again 5.9.
Clear everything, AC.
So this question ends here.
We are in complex mode.
For the interest
Else,
of
what
those
we
who
could
want
do
to learn
is,
more,
as I mentioned earlier also,
using
that
instead
you
of
go or
two
make sure that you go to
variables, we
alpha,
are just will plug in all three
and 2,
and the 3
so
by
we are
3
in
matrix.
complex mode. Now we need to enter these values, and they are in fraction form, so we'll select this, and on the top now we have 72 bracket 5 minus J2, that means 2i, minus bracket minus 12 plus 14.4j or 14.4i, bracket closed. Another bracket starts, -5 plus j4, that is 4i, bracket closed. So we have done with the numerator. Now we come to the denominator, bracket 15 minus j4, that is 4i, bracket closed, bracket 5 minus j2, 5 minus 2i, bracket closed, minus sign, bracket minus 5 plus j4, that is 4i, bracket close, new bracket, minus 5 plus j4, that is 4i, and so thus we have entered all the values. Now we just move here, put equal sign. So this is the answer we got. Again, we just press SD to get in the form that we are used to. So 6.05.063i, convert this into polar, shift, complex, polar 3 equal sign. So we get the same answer, that is 6.08 and angle 5.094. Form. And for that we are taking the first two equations and then the Supermesh equation again, but we have to just modify it slightly. This was the equation that we got. Now we'll bring all the variables on one side and the constant on the other side. So this will be I2 minus I3, and this comes on the right. And note that I1 is not there, so that means the coefficients of I1 is 0. So from here now we can write the 3 by 3 matrix as we did before. This component here, then this, and similarly all three. For I1 we have put in 0, for I2 it is 1, and for I3 is -1. And this as I had shown in one of my previous videos, we just plug in or name it A, B, C, D, etc., and we can use these 8 variables given A, B, C, D, E, F, X, Y, and M. I've just named it. And now with the help of calculator, again when when you see this slide, the technique is shown in, with the help of the calculator, how you can directly find this answer. Okay, so this is delta, just we have copied this whole thing, and delta 1, sorry, for this you can just write in terms of a B, C, D, the value of delta. So for the A, it will be Bx minus E, so A into Bx minus E, then we take minus B, and for minus B it is dx minus 0, so dx minus 0 or simply dx, and similarly for C we have d minus 0, so for C it is d. And also for delta 1 we replace the first column by the value of the output voltage, and same way we write an equation for delta 1. So y, then bx minus e, and all other terms. I hope you can follow this. And now if we use the calculator, this is the value of I, and now we'll use the calculator to get the value in one step. So when you see this slide, you will learn how to use this calculator for calculating this one.
It is slightly lengthy. Okay, so the answer we'll get is again 6.08, angle 5.94. Thank you.
Okay, whenever the calculator, you go to the calculator, the first step that you should do is make sure that you are in complex mode. If not, then the best way to do is that we clear by pressing AC, then press alpha, mode, and 2 for complex. So we are sure now we are in complex mode. Now in this case, we'll try to find delta 1 over delta. So it's a fraction, so we'll select this button here. And now we'll enter the values. The first value here is y. Now all these values you can see A, B, C, D, E, F, X and Y, M. These are the values that are available to us. So to get these values, we have to first of all press alpha and then any of the value that we want. Now we want Y first of all, so alpha and Y, then bracket bx minus e. So every time we have to press this, bx minus e, bracket close, minus b, bracket minus m e, bracket close, plus alpha c, bracket minus mb, minus alpha m, alpha b, bracket close. So this is the numerator part we have done. Now we are going to go to the denominator, so we press this. So we are in denominator, and denominator also we have to now write a bx minus e. So a bracket b x minus alpha e, bracket closed, minus b dx, b dx, bracket close, plus cd. So plus c and bracket d, bracket close. So this is how we have entered the values that were assigned for the matrices. Now we'll press calculate button here, and it will ask the values for various items. So let's see what is the value of I. Now y we have to see from the figure. So y, although it is showing some value, but we'll just ignore unless it is the same. So in our case y is 60, so we'll enter 60 equal sign. Okay, then is b. Now b is 4i. Fortunately it is showing 4i, so we'll just press equal. If not, you just enter 4i. Okay, then asking for x. X is equal to minus 1. We can just write minus 1. Although it is showing, we can put equal sign, but it is better that I write this so you understand. Then for E, now E is 5 minus J6. So it is 5 minus 6I. For J we write I, and I button is here over engineering. So 6I. Then is M. Now M is minus 24, not 24, minus 24. So we'll just write it again, minus 2.4, enter. C. Now C is minus 5. So C is minus 5 equal. A is 15 minus J4. So 15 minus 4I. Sorry, 15 minus 4I, enter. And then D is minus 5 plus J4. So minus 5 plus 4I. Okay, so this is the answer we have got, but this is in fraction form. If you want to see it in decimal form, then we press this SD button. So it is 6.0568 plus 063 I. So this is in rectangular form, which is shown in the slide. And now if you want to convert this into polar form, we have to press this shift and complex number 2 button. And then from here you can see this is polar form number 3. So we'll press 3 and equal sign. So this is the answer, 6.08, and the angle is 5.9, 5.94. So this is the answer that we get, and that is the correct answer.